Hello, my name is Radhaso Patil and I am going to talk about our work on developing a colorless green benchmark for syntactic evaluation in Indic languages. This work was done at BITS Pilani University under collaboration with students from Vellore Institute of Technology and Pune Institute of Computer Technology. Colorless green ideas slip furiously. This famous quote from Chomsky tells us about the distinction between syntax and semantics, where a syntactically correct sentence can be semantically nonsensical. This concept has been used extensively to study syntactic evaluation in language models previously. We will follow the same principle throughout our work. Indic NLP focuses on developing technologies for the highly multilingual Indian subcontinent where code switching is a common practice. The subcontinent has a rich linguistic diversity where more than 450 languages are spoken, which span across 7 language families. These languages are spoken by more than a billion speakers. Most of these speakers are potential new users which are standing behind a linguistic barrier for NLP-based technologies. Considering this, there have been many recent efforts to develop Indic NLP. This includes introducing new language models like MuRIL from Google Research India and IndicBERT from IIT Madras. There have also been multiple benchmarks to evaluate the performance of these models. This includes the Extreme Benchmark and the Indic NLP suite. Both these benchmarks only cover natural language understanding based tasks. Hence, syntactic evaluation has been largely ignored. Consequently, there is no existing formal evaluation paradigm or benchmark to evaluate syntax related knowledge in Indic language models. Our work aims to fill this research gap. But why do we need to develop resources for syntactic evaluation in Indic languages? To understand this, we need to understand the nature of morphosyntax in Indic languages. Morphosyntax in Indic languages is quite more challenging than English. Indic languages mostly follow free word order and are by default verb final languages. Most of the Indic languages have grammatical genders. Most of the Indic languages will also have a highly inflected morphology where case marking plays an important role. We will use Hindi as a demonstrative language in this work. Looking to the example at the right, we have an English sentence, Neha eats mangoes and Tom eats apples. If we look at the Hindi translation of this sentence, we see that the word order changes, where the word order in English is subject, verb, and object. In its Hindi translation, the word order becomes subject, object, and verb. Moreover, the verb eats is not inflected according to the gender of the noun in English, whereas if you look at its translation in Hindi, we see that the verb becomes khati for a female subject Neha and khata for a male subject Tom. Indic languages also follow code switching, where most of the languages are usually code switched with English. Script mixing is a common practice in code switch written text for Indic languages. Matrix embedding based code switching follow a very unique morphosyntax in Indic languages. All these factors make morphosyntax in Indic languages quite unique and different than other languages like English. Following the previous work in syntactic evaluation of language models, we use colorless green sentences in our benchmark. Colorless green sentences are syntactically correct and semantically nonsensical. Using these sentences for syntactic evaluation ensures that the language models do not leverage any semantic or lexical cues while syntactic processing. Since there is no existing dataset for colorless green sentences in Hindi, we use an already existing artificial method of generating colorless green sentences. This is done by replacing all the content words in a given sentence randomly. We use appropriate grammatical information while replacing these content words. This is done in order to maintain the morphosyntactic structure of the original sentence. If we look at the example to the right, we have an original sentence which is both syntactically and semantically correct. We then replace its content words with new randomly chosen content words from the given dataset. The point here to note is that the function words are not replaced and are kept as it is. We use already existing tree banks as a source of grammatical information. The tree banks which already exist for Hindi language have imbalance in gender-based tokens. So in order to maintain gender balancing, we perform a controlled replacement of content words so that both the male and female tokens occur with equal frequencies in the resulting dataset. We name our benchmark as Vyākarana, which is the Sanskrit term for grammar. The benchmark includes multiple tree banks. It includes the original Hindi Universal Dependencies tree bank. Using the previously described method, we also construct a colorless green version of this tree bank. Further, using automatic transliteration tools, we construct a code switch version of this tree bank. We include 4 evaluation tasks in the benchmark. At the token level, we have PoS tagging as the first task, which is a surface level syntax related task. Next, we have grammatical case marking. This is more difficult in Indic languages than in English. Unlike English, you cannot rely only on word order to determine the case of a given token. Instead, one has to rely on the morphological inflections and the adjoining adposition tokens of the token. At the sentence level, we have syntax tree depth prediction as a basic syntax related task. Further, we have subject-verb agreement. Unlike English, subject-verb agreement in Indic languages is a bit more challenging. Apart from the grammatical count, a verb also has to agree on grammatical gender with its noun. Also, most of the Indic languages are verb final by default. Hence, the number of intervening nouns between a subject and its verb is usually more than that in English. Looking at the statistics of our benchmark, we see that the original Hindi Universal Dependencies tree bank has significant imbalance in gender, which is resolved by using our methods. Further, we swap the train and test set of the original Hindi Universal Dependency tree bank while generating its colorless green version. This ensures that the training set is significantly smaller than the test set. This ensures a challenging test setting for the language models. To summarize the design of our benchmark, we see that it's gender balanced. We see that there are no semantic or lexical cues as ensured by colorless green sentences. We see that we have tasks of varying difficulties like PoS tagging versus subject-verb agreement. We see that there is a diversity in the tasks. We have token level tasks as well as we have sentence level tasks. We see that the benchmark is efficient with respect to the data where the test set is significantly larger. We also incorporate the code switching nature of Indic languages in the benchmark. We use the benchmark to conduct probing experiments with 5 different multilingual language models. We include 3 highly multilingual language models, including mBERT, XLM-R, and DistilmBERT. We also include 2 Indic multilingual language models, which include IndicBERT and MuRIL. We conduct layer-wise probing of the sentence level and token level representations of these language models in our probing experiments. We report the results from the last layer and the base layer from our probing experiments. Overall, we see that mBERT performs the best for syntactic evaluation related tasks. It majorly dominates on sentence level tasks, whereas XLM-R dominates on token level tasks and falls significantly behind on sentence level tasks. Under the code switching setting, we see that XLM-R performs the best for almost all the tasks. Both the Indic language models significantly fall behind across all the tasks and all the settings. We also study the phenomenon of syntactic localization in language models. From the previous studies of BERTology, it has been known that monolingual language models show syntactic localization, where maximum syntactic knowledge is stored in the middle layers. The highly multilingual language models also show similar localization, where we see that the performance peaks for mBERT, XLM-R, and DistilmBERT in the middle layers. Indic language models do not show such syntactic localization. Their performance keeps dropping across the network as we go deeper. This might indicate inefficient pre-training of the Indic language models. Concluding our work, we see that we present the first benchmark for syntactic evaluation in Indic languages. This benchmark can be used for developing Indic NLP, or it can also be used as a general purpose benchmark for multilingual syntactic evaluation. Our experiments show that the current Indic language models do not capture syntax efficiently. They are mostly outperformed by highly multilingual language models like mBERT, XLM-R, and DistilmBERT. These models are also outperformed under code switching setting, which is unique to Indic languages. We also see that current Indic language models do not show syntactic localization, unlike other monolingual and multilingual language models. We are currently planning to expand this benchmark to other Indic languages. We would like to thank you for attending our work, and you can contact us here. Thank you.